following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Let's begin here by reading our question. Example, convex mirror, finding image distance, magnification, and height of image. An object with a height of 3 centimeters is placed 20 centimeters from a convex mirror with a focal length magnitude of 8 centimeters. Determine the following: location of the image, magnification, and height of the image. Now, again, I encourage you to pause the video and attempt solving this problem independently. Otherwise, you're more than welcome to follow along. Now, before we even do this problem, there's a few things, or we can say a few assumptions that we can make. Looking a little bit closer here at the location of the image, we know that the image distance should be negative, considering the image is virtual and behind the mirror. Secondly, the magnification of the mirror should be positive, thus we expect the image to be erect. And the magnitude for the magnification of the mirror should be less than 1, since the image distance's absolute value is less than that for the object distance, which in turn results in a reduced image. Now, if the image is reduced, then the height of the image will be less than that of the height of the object. All right, let's take a closer look at our scenario, and for that we'll use figure 35A. Here we have a sketch of the scenario taking place, but note that this sketch is not to scale. We're first being asked to find the image distance. We're given the distance of the object from the vertex, which is 20 centimeters, and the focal length, which is 8 centimeters. Note, though, that the focal length is negative, since we're dealing with a convex mirror. From the information provided, we have enough to solve for the image distance. Let's do that now. Coming over here, as we demonstrated earlier, from the mirror equation and magnification equation, we can solve for the image distance, which leads us to the following equation here. Next, if we go ahead and we fill in our values, and in doing so, we find that the image distance is going to be negative 5.71 centimeters. Now that we have the image distance, we can easily find the magnification. Let's do that on the next slide. Okay, let's get right into it and start with our magnification equation. Beginning with the magnification equation, all we need to do is fill in our values. The image distance is negative 5.71 centimeters, and the object's distance given to us is 20 centimeters, and upon solving, we find that the magnification is 0.286. Recall, magnification is dimensionless, and as we expected, it's positive, and the magnitude is less than 1. Now that we know the magnification, and in our problem we're given the height of the object, we can easily go find the height of the image using the magnification example. Let's go ahead and do that now on the next slide. Okay. Now we'll find the height of the image. And again, let's just get right into it. For the height of the image, it's simply just going to be our magnification equation, and we can go ahead and solve for the height of the image. And once we go ahead and we fill in our values for magnification and the height of the object, which is 0.286 and 3 centimeters respectively, we find that the height of the image is going to be 0.858 centimeters. And as we had anticipated, the height of the image, which is 0.858 centimeters, is less than the height of the object, which was 3 centimeters. Okay, great. Let's proceed to our next slide where we can do one more example. Now, here we're being asked, example, convex mirror, finding radius of curvature. What is the radius of curvature for a